Okay, now let's talk about a bit of abstract level concepts on what hashing is. So hashing is a complex mathematical calculation to map data of an arbitrary size to a fixed length value. Now, what am I trying to say here is whatever the length of the text is, so it can be a single letter or a million lines of text. So whatever arbitrary size the data can be, we can pass the data through a hashing function, and the resulting hash will always have the same exact resulting size depending upon the hashing algorithm. So in this case, I'm using SHA-1, right? So I wrote this in this image, this is a video tutorial about a story behind wireless hacking, and this particular example gives a small hint of what hash is, and I'm going to convert this to SHA-1. So when I converted this to SHA-1 using an online service, I got this value, this set of random strings, which means nothing basically. We got this value, which is exactly 20 bytes or 160 bit in length. That is the rule for SHA-1, which means the arbitrary size of data, if you pass it through SHA-1, it will always spit out a value which is 20 bytes or 160 bits. So one of the very trivial factors of what hashing means is any given two words which are exactly identical in plain text should always represent a hash value which are identical as well. So if the two words are hello and hello, if you convert that to SHA-1, the resulting hashes for the both of the words should be exactly identical, and this property is what is used for authenticating users nowadays. So when you log into a website and you provide in the password and hit enter, that password is hashed with a hashing algorithm that is decided by the website, and this hashed value is then sent to the server. Now the server queries their database for your saved version of the hash, which is actually saved onto their database, and when the hash is exactly identical to the hash that the user just typed in, then the user is authenticated to use their services. So now you can realize that whenever we use two identical words, their hashes should exactly be same as well. Another important trivial factor of hashing is that two non-identical words cannot ever spit out an exact identical hash value. So this phenomenon is called a hashing collision or a hash collision, right? So what am I trying to say here is if you take two words, for example iPhone and Android, and if you hash them using SHA-1 and the resulting hash is identical, then it's a hash collision. We cannot use that hash because then two words represent same things, right? So that is not good. That's why we do not use MD5 anymore. Now MD5 was very much susceptible to hash collisions. Now the first collision for SHA-1 has also been reported back in 2017, but SHA-1 is also very secure because it uses a lot of CPU cycles, and that is what's needed for a secure hashing. But it's also susceptible to hash collisions. But again, if we use SHA-1 hashing in a different way, which I'm going to cover in the next videos, then SHA-1 is very secure as well. No problems in that. Now, another very much important function of hashing is that hashing should be completely irreversible, and hashing is irreversible. So what I mean by that is this value, this piece of random strings represents this text, right? Now if I cover up this text and you can only see this part, you can never get this value back from the set of strings here, but also it represents this exact same text, which means that if you copy this text into your computer and hash it with SHA-1, you are going to get the same exact value, but if you only have the value, you cannot get back to this plain text from this hashed value. So hashing is completely irreversible, and that is what makes hashing so much fun and secure, because it's never reversible. Now one of the key differences between hashing and encryption is that hashing is completely irreversible, whereas encryption is made to be reversible, and that is what makes hashing fun and secure, because you cannot ever get back the original data. But in case of encryption, you use a key to encrypt some plain text to a ciphertext, and you can use that same key for decrypting the ciphertext back to the plain text. So as I said in the previous video, that when we use encryption to store passwords in the database, and if a hacker is able to grab the password or grab the key, then regardless of how hard the password is, it can crack the password out by simply decrypting the encrypted message. So in case of hashing, you cannot actually do that, because if a password is hard enough, then there is a less probable chance that a hacker can guess what the password was. And this is called a brute force attack, which I'm going to practically show you in the later videos. So now I think if I just show you one example, that is, this is encryption, right? Encryption using electronic code block mode. So I'm not going to be explaining what electronic code block is. So AES is basically what we call a block cipher, which is different than stream cipher. Now you can read these things up by yourself, but let me just say that AES uses block cipher, which means that AES encryption takes a message, breaks them into fixed length sizes, and then encrypts each of those blocks to get an encrypted text. Now if I take this example, which is similar to this one right here, so if I take this example, which is, this is a video tutorial about story behind wireless hacking, and this example will show you a hint of what encryption is, and we are going to convert this to AES ECB with a key. So now I used a key, the key was hello, so I used the key hello to encrypt this piece of plain text back to this encrypted message, and I can use that same key to decrypt this message back to this plain text. Now in case of encryption, this is called a ciphertext, this is called a plain text, and this is the key which we use to encrypt or decrypt. So encryption is completely reversible, whereas hashing is not. So by now you know the properties of hashing and the difference between hashing and encryption. In a recap, hashing is a calculation to map arbitrary size data to a fixed length value. Secondly, it cannot have hash collisions. Thirdly, two identical words have to always convert to a hash value, which also has to be exactly identical. And fourthly, hashing has to be completely irreversible, right? So now let's move on to the next chapters.